Here's a clever problem. Usually we transfer double integrals in terms of x and y, rectangular coordinates, Cartesian coordinates, to polar coordinates integrals. This problem is asking us to go in the opposite direction. So here we have an integral that's set up, a double integral I should say, that's set up with polar coordinates. Let's write this as Cartesian coordinates, one in terms of x and y. Okay, so what's going on here? Theta runs from 0 to pi over 4, and r runs from 0 to 5 secant theta. So something that we know we're going to need is, okay, I think we know what theta is 0, theta is pi over 4, r is 0. I think we know all of that looks like. What does r is equal to 5 secant theta? Well, 5 secant theta is 5 over cosine theta. We cross multiply. Our cosine theta is equal to 5, but our cosine theta, this is y. So this is, sorry. I'm being silly here. That is x. X is our cosine theta. Sorry about that. So this is really the line. X is equal to 5. So now let's draw a picture to see what's going on here. So theta is 0. That is the positive x-axis. Theta is pi over 4. It's the line y is equal to x right here. And then we also need the line x is equal to 5. And so r can run from 0 to 5 secant theta. This is the line x is equal to 5 here. And so what do we see? Our region is just going to be a triangle. So the bounds here in terms of x and y, going to be x runs from 0 to 5, and y for a particular value x runs from 0 to x. X runs from 0 to 5, y runs from 0 to x, dy dx. Okay, so the last thing we have to do now is to rewrite the integrand. So our original integrand right now is r to the 5th cosine squared theta. We should know that this can be rewritten. First off, we know we need to split off a factor of r. And so this will be r to the 4th times r dr d theta, because that r just goes along with the dr d theta. We know by now that's coming from the Jacobian. And then I'm going to write the remaining r to the 4th as r squared times r cosine theta quantity squared. So let's just check this. That we have r squared, r, that's r to the 5th. We have cosine squared theta. Everything's fine here. Why did I make these changes? So this r just gets sucked into the Jacobian. R cosine theta, we already said that was x here. So that's going to be x squared. And r squared, we should know r squared is x squared plus y squared. So our integrand goes from this to x squared plus y squared, all of that times x squared. We go in the reverse order. Everything here would check out. So yeah, clever problem, asking you to do the conversion in the opposite order from what we're used to.